All right, guys. So happy Wednesday. We made it to Hump Day. I'm going to start off today's class just by previewing a little bit with you guys. So get to the page here. Whoops, I got to minimize this stuff, guys. Hold on. All right. So this quick review, okay? Because this is going to be on your Edge Elastic. So rather than you just jump in your Edge Elastic, I'm going to have you guys watch me work through these a little bit. Then I'm going to have you guys attack them on Edge Elastic. Then we're going to get into the modules for today. So let's see if I can get my dot cam going here. So let me get my ladybug going. Give me a second, guys. All right, so we have some shapes. So if you look back at the original problems, be bouncing back and forth a little bit here. Okay, so we have these problems right here, right? Okay, so it's going to ask you today. I gave you 4 triangles because we talked about them yesterday. We played around with them. You were breaking the shapes up. Today, your job is to find the area of those shapes. So I'm going to look at A specifically. Okay. You could do all kinds of ways. I'm going to show you on a piece of paper a couple different ways you can attack it. The way I would suggest is to make a copy and then cut your answer in half. So, Ms. Fisher, I don't get it. What are you talking about? So I have to find the base of the triangle and the height of the triangle, and then I'm going to make a copy of that shape. So I'm going to pop over to my dot cam. So I drew that same shape. Okay, drew the same shape for you. What I'm going to do today, this is the easiest way to calculate these. There's a lot of ways you can do it. But this is the easiest way. I'm going to make a copy. So I make a copy of this. So from here to there, there, to there. Okay, the reason we're doing that again is so that we can make a rectangle. Okay, so once I make the rectangle, where'd my thing go here? Sorry. There we go. Drag this guy up. Drag this guy up. Okay, so I've made a rectangle out of my shape. And the reason being, guys, is I know the area of a rectangle is literally just base times height. So we're going to find those 2 dimensions. So I have my base, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to mark that on my sheet. Okay, so hopefully you're doing these Edge Elastic problems on paper. You're not trying to do these in your head. Okay, because it's a requirement. Mom and dad come asking. That's one of the pieces of class. I look for my height. It's 2. So I go and place a 2. At this point, I can find the area of the rectangle because I know that the base times the height is going to give me the area of my rectangle. Okay? Well, in this case, my base is 8. I replace my base. My height is 2. My area is obviously going to be 16. Okay? For this problem. What I want you to see, though, is only half of that object is the triangle. So from here to here was not included. Remember? That was not included. The original triangle is this. The original triangle is here. So if I have this, here's my original triangle. So looking at that, what we kind of came up with yesterday is a triangle is half. So a triangle's area is 1/2 the area of the rectangle. So 1/2 the area of the rectangle. Well, I would attack it the same way. It's literally just 8 times 2, but it's half of that dimension. Half. You're taking half of what the answer is. Well, we found the answer was 16, right? 8 times 2 is 16. So my area is literally just 8. So we're not going to try to cut up the triangles and do all craziness like that. We're literally just working through the problem, trying to find out the area of the triangle. All right, second question. Okay, looks like B. So problem B. And again, it's goofy looking. It's not a right triangle this time, so it might throw you for a loop, but I can make a copy of it, glue it to it. It's not going to make a rectangle, nor is it going to make a square, because I don't really see any 90s. You could, but I don't want you to freak yourself out. So we're going to make a parallelogram in this case. So if I go to B, I'm just going to make a copy of it. I make a copy in my head. I flip it upside down. So it's going to look like this time. It literally looks like that. Okay? So there's my parallelogram. It's not pretty, but that's the point. I go back. Again, I know the area of the triangle is half of the base times the height, because a parallelogram's area is base times the height. So I look, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. So the height is 3. 3 squares tall. Remember, I count 1 square tall, 2 squares tall, 3. I can use the height over here. 1 square tall, 2 squares tall, 3 squares tall. The base is 1, 2, 3, 4, 5, 6, 7. So I go back to my problem. I'm putting my base in as 7. Remember the vertical height. The vertical height is 3. That's my 90-degree angle. Always has to be perpendicular. The height has to be perpendicular to the base. Okay. This time I'm going to skip writing the formula of this because it's already embedded. It's A is equal to the base times the height, right? That's the area of a parallelogram. I don't want that this time though. I only want this triangle. I just want the triangle, so I'm going to put that 1/2 in front of it. That's literally the area of a triangle. Now all I have to do is plug the information in. So I look for my B. Well, the B is literally telling me it's a 7. Okay, this is all multiplication, by the way. It's base times height, and it's 1/2 of, which means times. The height is 3, so I put a 3. And then I'm taking 1/2 of whatever that answer is. So my area then, 7 times 3 is 21. And I'm taking half of that, which is multiply. In reality, at the end, you're dividing because you're doing 1 times 21 divided by 2. You don't need to know that. You just take 21, so pretend you had $21. You cut that in half. Well, half of that would be 10.5. Or you could put 10 and 1/2. It's the same exact stuff. Okay, remember, here is this piece. Okay, here's my rectangle, my parallelogram in this case. All right, here's my parallelogram. Right, and then here is my triangle. This is what I need. My triangle here. And if you notice, it's half of that object. That's where this comes in. It's half of this 21. That's literally what's occurring. All right. My next one is this object. So say this popped up on a quiz, and wink, wink, test for your edge elastics. Here's my third shape. Again, I don't see any 90s. I see an acute angle, an obtuse angle, and an acute angle. But I can still find the area of this thing. I need to find a base. I need to find a height, and I need to make a copy. So let's go over, we're going to make a copy. Okay, so I go over my drawing. And again, my drawing's not perfect, but make a copy. In this case, I'm going to make a parallelogram. Pretend this is perfect, and it's a parallelogram. Okay, we made a copy of the shape. I flipped it upside down on its head, glued it to it. I still know the area of that shape, parallelogram, is base times height. But I only want half. I only want this half. I don't care about the other half. Okay, it's helping me to find the base and the height because I don't want to break this thing into triangles and have to move things around. This is literally where we're decomposing, breaking a shape up, and then putting it back together. So I have to add that 1/2 piece. So 1/2 base times height. Okay, remember, in mathematics, guys, that you don't have to put time symbols. If you put a letter next to a number and a letter next to a letter, you're multiplying those numbers. Okay, let's go back and look to see if we can find the height and the base. So I go up. I know that this usually is flat on the bottom. Sometimes I can pick any side, but I want to be able to count it in squares. So keep that in mind. So if they give you a funky looking shape, I don't really know how tall this is. Okay, because if I do the height, it's from here to here. That's not along this line. But I can. This one's perfectly flat. You see how it's flat along the squares? So I can do 1, 2, 3, 4, 5. That's my base. So we're going to go plug in my base. My base is 5. I replace it in my formula. Okay, I go back. My height. It's just how many squares tall from this point all the way down perpendicular, to the base. So I have 1 square, 2 squares, 3 squares, 4 squares. And to give you a visual, this is what's occurring. The height of this thing could be here, 4 squares. The height of this thing could be here. The height of the thing could be here. It really doesn't change. It's still 4 squares tall. So if you go back and look at this, anywhere you would start from this base, if you went 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, it doesn't matter where it's at. The height of this object does not change because it's parallel to the base. Okay? Regardless, I go back, I plug in my height of 4. I'm going to put it over here. It really doesn't matter where you stuck it. Then I go back in, I know that's my height, so I put in the 4. I include my 1/2. That's a dot. It's times. Then I'm going to take my product. Here's my parallelogram. Base times height. The area of that parallelogram is 20. But then at the end, I need to take 1/2. So 1/2 times the 20. And then I have half of 20 is obviously 10. So the area of the orange shaded part, the orange part, is 10. That would be the area of that. The area here that you found, this base times height, is 5 times 4, and this 20 is this object. This is green. So this is what I'm trying to explain to you. We turned it into a parallelogram, so we can just find its base height, multiply it together. At the end, I whop it in half. That's the easiest way you can do it. Okay, there's other methods we learned, but I'm trying to show you the easy way. Here's problem D. Okay, last one we're doing. I'm going to go to my diagram. It's over here. All right. I still need A is equal to. I'm going to speed this one up a little bit. 1/2 base times height. Should be kind of sinking in here. Okay. Again, here's my mimicked image. I know I'm going to draw another parallelogram because there's no 90s. Could have been on top, could have been on the side, whatever you like. Okay. I go back to my diagram. I'm looking for a base and a height. Miss Fisher, dude, I don't see a base in this case. So, well, I have a line that's right along the squares here. So pretend this thing was like flipped on its head. Pretend it looked like this. If I flipped it, it's really like that. But on the computer, you can't take your computer and turn it sideways. Okay? Or at least I can. So you have this, right? Well, I would take this. All I need is my base. Well, that's 1, 2, 3, 4. So on my piece of paper here, I'm going to replace my base with 4. Okay? I'm looking for the height. How far is it from this base to the very, very peak of that triangle? Well, it's 1 square, 2 squares, 3 squares, 4 squares, 5 squares, 6 squares. So it's 6 squares tall. So from here to here, here to here, remember it's a 90-degree angle, is 6 squares tall. So the base would be 4, the height would be 6. Even if you went from here, you went outside of it, way down here, it's a 90-degree angle compared to the base, it's still 6, regardless of how you attack it. Okay? All right, so I have a 4 times 6. That 4 times 6, remember, this is the area of the parallelogram. But I only want half. I only want the half that we initially had. I'm trying to find the area of this object, not the parallelogram. I use the parallelogram to kind of cheat, because I know how to do base times height really simply. Okay? But in this case, I do 4 times 6, 24. I take 1/2 of that. My final area gives me 12. Okay? So hopefully this makes sense, guys. And again, I'll highlight this so it makes, I know some of you guys are visual kids. This is color-coded. And that would be this guy. That would be this piece here. Base times height, 24. My orange piece is this guy here. That's the 12. Okay? That's literally what's occurring in this. Hopefully that helps you. And then after we're done watching this and going through, I'm actually going to take you through this in class. Say you didn't understand it, it didn't make sense. I don't want you guys attacking the edge elastics until these are complete. All right. If you have questions, please watch the video. You can email me. Tomorrow morning is tutoring. I'm going to be covering the area triangles with you. Okay. All right. See you guys later.